In the world of science, scientific breakthroughs often happen when you least expect them, shaking the foundations of established knowledge. Today, we find ourselves on the brink of such a major discovery. One of today's most prominent and cutting-edge physicists, Michio Kaku, recognized for his outstanding contributions to the fields of physics, recently confirmed something that has the potential to rewrite our understanding of the universe. The James Webb Space Telescope has discovered 6 massive galaxies that scientists previously thought could not exist. This research has the potential to open up new dimensions to our scientific understanding, making this an exciting time to keep a close eye on. Dr. Michio Kaku, a notable figure in the scientific community, is a physicist of American and Japanese descent. He is considered an expert in classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku has always been receptive to the surprising results of the James Webb Space Telescope mission. We are delighted that this eminent scientist has decided to break his silence and share publicly what is no longer undeniable. The enthusiasm and almost amused tone of the famously brilliant physicist is evident in his comments about the discovery made by the James Webb Space Telescope, expressing that this is what piqued his interest. The significance of Michio Kaku's discovery of these 6 giant galaxies is profound. Kaku was a scientist who was always willing to consider new theories throughout his life. He knew that Einstein's equations of relativity and Newton's laws were insufficient to grasp the full complexity of the universe. Kaku understood that the new telescope's findings had the potential to enrich the scientific field, even if many of his colleagues could not accept this view. This discovery sparked concern and insomnia among Big Bang advocates and opponents of quantum mechanics. But the discovery only made Michio Kaku laugh. The James Webb Space Telescope has revealed the discovery of 6 massive galaxies that date back to the early universe. Each of these galaxies contains more stars than our own Milky Way, even though they didn't form until 200 to 700 million years after the Big Bang. The team of astronomers who made the discovery have dubbed these particular galaxies the cosmic breakers because, if confirmed, they would revolutionize our entire understanding of the universe. Something's not right here. The Big Bang theory tells us that the universe was completely chaotic after the initial event. It took hundreds of thousands of years for the first solid objects to form, and hundreds of millions of years more for these objects to become dense enough to produce light. The formation of complex structures such as galaxies is thought to have occurred much later. Some newly discovered galaxies are larger than the Milky Way, and their enormous luminosity suggests that they may be forming hundreds of new stars every year, while our galaxy forms stars only sporadically. It is not known exactly when the first galaxies formed. Researchers have not yet been able to determine this. The only thing that is certain is that in the beginning there were only single stars or groups of stars, which then grouped together to form increasingly larger accretion regions until dwarf galaxies appeared. Small galaxies met other galaxies and gradually grew larger. According to previous theories, massive and highly organized galaxies could not have existed at that time, raising the question of whether the universe was much older than previously thought or whether complex arrangements of toroidal galaxies had developed much earlier. This situation is difficult to accept for conservative science, which has always found problems with this model. Some branches of physics flatly refuse to accept this finding and question possible errors in the age calculations. Michio Kaku was aware of this and said the following: "There are many examples of old and erroneous theories that stubbornly persist due to the prestige of certain scientists. Many of these theories are only discredited when a crucial experiment shows them to be wrong. Therefore, the fundamental work of any science, especially physics, relies on experimentalists to ensure that the theorist remains honest. In fact, on Earth, we know very little about the true beginning of the universe. The Big Bang theory was proposed in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the universe originated from a single point and has been expanding ever since. At that time, it was difficult for people and scientists to imagine a universe with a beginning and an end. The idea of a universe that has always existed and is infinite in time and space was beyond the imagination of people and scientists. Even today, scientists still have difficulty understanding it. However, it is important to reconsider these probabilities. These new evidences do not correspond at all to what researchers have relied on for decades based on the Big Bang theory. However, science has proven time and again that reevaluation and openness to new ideas are an integral part of the scientific process, as is the confirmation of certain theories through observation. When Einstein was a child, it was believed that stars and planets were firmly fixed in the universe and that these specific structures occupied a defined space. However, we now know that everything in the universe is in motion. Planets orbit stars, stars move through their galaxies at speeds of hundreds of kilometers per second, and entire galaxies move rapidly through the universe, their fates not even predictable to us. Today, scientists are challenged to accept hard facts and understand that theories are more than just guesses and are not absolute truths until they are rigorously tested or confirmed by precise observations. The idea of the Big Bang was born from the observation that galaxies were moving away from each other and that this distance was proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, things like the cosmic background radiation and the red shift of light from distant galaxies and other cosmic structures seem to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the Sun revolved around us also had this evidence to support their theories until coincidences or technological improvements came along and made a clearer conclusion, more accurate picture that we are in the same situation now. Scientists hoped the new James Webb Space Telescope would confirm theories about the Big Bang, but they stumbled upon these 6 galaxies, which seemed unlikely. This reminds us that science is constantly evolving and that scientists must be open to new discoveries and rethink existing theories based on available evidence. Researchers use redshift as a tool to measure certain quantities in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light when the light source and the observer move relative to each other. To understand this, imagine that you are standing still and see a car speeding towards you. As the car moves towards you, you hear the engine noise getting louder. However, as the car passes you or moves away from you, the engine noise changes. This is because engine noise changes as the car moves. The same thing happens with light. As a light source, such as a distant star, moves towards us, the light we perceive shifts to a bluer hue. On the other hand, as the light source moves away from us, the light becomes redder. This phenomenon is called redshift. Physicists convert redshift values into speeds and distances to measure them in cosmological studies. However, it is important to note that small errors in these measurements can have big consequences. The measurement techniques used so far are currently being revised, and it will be interesting to see what results scientists will achieve. When it comes to the latest evidence related to our universe, one has to wonder whether they are really based on redshift errors or whether some scientists simply deny the truth. This is a question that requires close analysis and careful consideration of the data and methods used in the study. Thank you very much for watching the video. As always, we remind you that you can post your doubts in the comment box. If you liked the video, don't forget to like it, share it so that it reaches more people and subscribe to the channel so that you don't miss out on content like this anymore. Thanks so much for watching and see you in the next one.